Everybody, if you had questions on number 1 in the review packet, let's go over it. We're going to find the slope of DE. So to start for finding slope, I like to do y2 minus y1. Make sure that you do the y values on top. And then in the denominator, we'll do x2 minus x1. 4 minus negative 3 is 7. Negative 7 minus negative 5 is like negative 7 plus 5, so it's negative 2. I can check in my calculator, but that's not something that I can simplify more. Now let's do the exact same thing, but with E and F. So first you want to start with the y's. So let's do y2 minus y1. Then next you want to do the x's. So let's do x2 minus x1. Negative 10 minus 4 is negative 14. Negative 3 minus negative 7 is like negative 3 plus 7, so it's 4. You'll want to simplify this. You can either use the fraction button on the calculator, or you can just divide the top and bottom by 2. But when you simplify, you'll see that you also get negative 7 over 2. So you never want to decide whether or not the points are collinear until you've simplified the fractions. So are the points collinear? Yes, because the slope from D to E is the same as the slope from E to F. Make sure that your explanation has something to do with the word slope. If you haven't included the word slope in there, you probably haven't done enough. So if you just said yes because they lie on the same line, I want to know a little bit more. How could you prove that they lie on the same line? All right, finally, the last step is the most challenging one. It says that there's another point that's collinear with D and E. So we know that the slope of DE was negative 7 halves. Slope of DE, negative 7 halves. All right, let's find the slope of, for example, EG. So we have E at negative 7, 4, and we have G at x comma 18, and we want to do our thing again where we find the change in y. So let's do that on top, 18 minus 4. And then we want to do the change in x on the bottom, x minus negative 7. And then let's simplify. So 18 minus 4 is 14. X minus negative 7 is x plus 7. And I want to set these two slopes equal to each other, because if G is collinear with D and E, then the slope of EG must be equal to the slope of DE. So negative 7 halves equals 14 over x plus 7. There's a bunch of different possibilities for how to solve this. I'm actually seeing that the easiest possibility might be to take the slope of DE, and if you multiply the top and the bottom by negative 2, which you're allowed to do as long as you do the same thing to the top as you do to the bottom, you get 14 over negative 4. If I replace my slope of negative 7 halves with my slope of 14 over negative 4, then I have numerators that already match up. And all I would have to do is set the denominators equal to each other. So I make that little equation. I want to solve it for x, so I'm just going to subtract 7 from both sides, and I get x equals negative 11. That's my solution. If you wanted to check if you did it right, my advice would be to go to Desmos, plot your 3 original points, D, E, and F, and then plot your new point for point G, which is instead of x comma 18, now we know that it's negative 11 comma 18. Let me know if you have any questions.